Let's start with vocabulary. Let's say I had this expression, 5x plus 3. We're going to use this expression to define variables, coefficients, constants, terms, expression, and equation. First of all, this entire thing, we would call this an expression. An expression is another way to say a math sentence. Now, within our math sentence, we have an x, and this is considered our variable. Now, it's a variable because it can change. Not only can my variable be represented by a different letter, but it can represent different numbers. Now, we need to define what our variable is because often it represents something. So we could say, let x be the height, or let x be the width, and we're going to substitute the value of that into x. Now, the number that we have multiplying our variable is called the coefficient. Coefficient, by definition, is a number that is multiplied to the variable. Now, I make this distinction because this number is different than this number. 5 is attached to the x, and together it forms a term. This is our coefficient because it's attached to the variable. On the other hand, the 3, we would call this a constant because regardless of what the variable is, plus 3 doesn't change. And we can look at this expression and classify it by the number of terms. A term is a segment of the expression or an equation, and it's separated by an operator, such as an addition, a subtraction sign, or an equal sign. As for expression and equation, we'll get into that more, but an expression is just a statement, and an equation has an equal sign in it. So 5x plus 3 is an expression. An equation would be something like 5x plus 3 is equal to 2. Let's talk a bit about naming our polynomial based on the number of terms. These are some prefixes that we use to describe our polynomials. The prefix mono means 1, bi means 2, tri means 3, and poly means more than 1. So when I have a monomial, an example of a monomial would be something like x squared. It has one term. We could have a monomial that has a coefficient too. So I could have 3m to the power of 5. Or I could also have a monomial that has multiple variables, 8 or sorry, 8xy z squared. This is all considered one term because these are multiplied together. And we said that terms are separated by operators such as addition and subtraction. Okay, so talking about a binomial, we would be speaking about something that has two terms, x squared plus 5. That has two terms. 3m to the power of 5 minus xy. Or we could have 8xyz squared plus 9mn. A trinomial is something that has three terms. So let's say we had x squared plus 5x plus 8. We have three different terms. Another example, we could have 3m to the power of 5 minus xy plus z squared, or 8xyz squared plus 9mn minus 5. And once again, the word poly is something that it has more than one term. So all of the above, the monomial, binomial, and trinomial, these are all polynomials. So let's do this example here. Identify the coefficient, the variables, and the constant. How many terms does each of these expressions have? So just a reminder, a term is separated by the operators plus or minus or an equal sign. So when I look at here, I have one term, two term, three terms, and four terms. Now this one looks like it might have more than uh, four terms, but this is a fraction. So because it's a fraction, we still consider this one term. Okay, the coefficients. Coefficient are the numbers that are multiplied to the variables. So in this case, 19 is a coefficient. 5 is a coefficient. 6 over 5, or you could separate them as 6 and 5. Those are also coefficients. Negative 4, though, is not a coefficient because it's a constant. It doesn't have a variable, so it's just a number, and we call that a constant. Finally, our variables. We have the letters M, N, P, and R. Okay, second example, 3x squared plus x minus 10. We have three different terms. Here's our first term, second term, and the third term. Our coefficients, we have a 3. Now this one is a little bit tricky. With the x, there's no explicit number written beside the variable. So if we don't have a number, the assumption is that there's 1. The reason we don't write the number 1 is because it's a bit redundant. Like if I say that there is one Miss Fan in the classroom, it's the same as saying Miss Fan is in the classroom. So I just say Miss Fan is in the classroom instead of giving it with a number. Now our variables in this case, we have two different variables. One variable is x squared. Another variable is x. Now we know that these are different because x squared means x times x. Finally, our constant, we have a negative 10, and so our constant, negative 10. Okay, pause the video and answer these on your own. Okay, in this slide, I want you to try these questions on your own, but I'm going to take these up. Now, when we're ordering our polynomials, we have to first order them alphabetically. And if we have an alphabet letter that is the same as another one, then we order them based on descending order of the exponents. So let's look at our example here. We have the variables p, m, k, q cubed, and m squared. So first of all, we would have k. The next letter would be m, but we have two m's here. So we have a repeated alphabet letter. We order it now by the exponents. We're going to go from m squared, then m. Now we can go back to our alphabet, the letter p, and then q cubed. Second example, let's do the same thing. Put them in the correct order. We have y to the 5, x. We have a y, x squared, a 5, 4x cubed. Let's start with the x's. So 4x cubed. Then we have x squared, x, y to the 5, y, and finally we put 5. So after we put all the terms with variables, we put the constants at the end. Okay, the next part, we're going to talk a bit about like terms. Like terms, I like to think of it as fruit. So fruit, we have apples, these are the same, and lemons, these are the same. Now, if we are adding apples together, then we can combine them, but I can't combine two different fruit and say I have a basket of apples. When I say exactly the same, I mean things like apples. But apples are different than applesauce. But applesauce is different than apple juice. So these are similar, but they're not exactly the same. So if they're not exactly the same, then they're not considered like terms. Let's look at this. I have 4c, 2c, negative 6c. What's the variable that we have? Just c. Are these like terms? Yes, they're like terms. The coefficients doesn't matter, but the variables are all the same. Okay, let's look at example B. Negative 2x squared y, 13x squared y, and x squared y. What's the variable we're dealing with? We're dealing with x squared y. Every single one of these terms have x squared y. Yes, these are like terms. The last example, we have 3p squared q, 2p squared, and 6q. We've got three different terms here. And even though they're similar, they're not exactly the same. So p squared q, that's the first term or type of terms we have. P squared, that's another type. And we have q. They're not like terms. Okay, state all the like terms in this polynomial and rewrite them in order. What we're going to do is we need to write it in alphabetic order, and then we're going to combine them. So remember, we start with the letters in alphabetic order, and if we have double letters, we're going to start with the highest exponent. So first, I'm going to have 6x squared y minus 2x squared y. So I've covered those two. Then I've got the x's, plus 4x plus 16x. Finally, minus y squared plus 10y squared. I have rewritten this in the correct order based on math convention. Now, because these are like terms, I can simplify these. It says that I'm subtracting, so we're going to take our coefficient and subtract them. 4x squared y, that accounts for the first two. Next, we have 4x plus 16x. That gives us 20x. And finally, negative 1y squared plus 10y squared. So positive 9y squared. Pause the video and try these on your own. Right here are the solutions to the first two that I wanted you to try on your own.